6.1, rate of change and slope. Slope is the ratio of the vertical change to the horizontal change. Ratio means it's a fraction. So we use the letter M to represent slope. Again, vertical change over horizontal change, which is sometimes called rise over run. And then here's the slope formula. This is very important for you to remember, not only for this class, but for future math classes as well. It gets used a lot. So there's four types of slopes that we have to be aware of and be able to identify. So looking at our first graph on the left, if we see a line that from left to right is slanting upwards, that's called positive slope. If you see in the second graph a line that is slanting from left to right downwards, that's called negative slope. A horizontal line has a slope that equals 0. So it has a numerical value, it's just 0. And then important, if you see underneath the graph, something you should add to your notes, you know you're going to have a 0 slope whenever you end up with 0 in the numerator of your fraction. And then the last type, vertical lines, have undefined slope, or sometimes it's said no slope. That would be something to add to your notes. And then underneath the graph here, add this as well. The slope is going to always be undefined when you end up with a 0 in your denominator. And then we have rate of change. The nice part about this is that rate of change is just another name for slope. They work the exact same way. The only difference is rate of change a lot of times will have labels that need to be that need to go along with it. So again, since it's the same as slope, we use M. It is slightly different in that the rate of change is always calculated using the change in the dependent variable over the change in the independent variable. Independent and dependent variables are something that we've talked about. If you remember, independent variables are the ones that you have more control over. They are the ones that affect what happens with the other one. The dependent variable is the one that is affected by the independent variable, or it depends on the independent variable. We can still use the same idea of rise over run as we can with just regular slope. And again, since it's just like regular slope, we'll use the exact same formula, y2 minus y1 over x2 minus x1. So the first example we're going to go through is finding rate of change using a table. So we're asked, in this table, is the rate of change the same for each pair of consecutive mileage amounts? Consecutive just means the ones that are next to each other in the table. So first thing we have to do before we can even start finding rate of change is we have to figure out what are the independent and dependent variables. If you think about the kind of situation here, the fee would depend on how many miles are driven. So that makes the fee the dependent variable and miles the independent variable. And you also think about you control how many miles you drive. If wherever your destination is, you pick that destination, you're in control of that. So that would be the independent. So since we have our independent and dependent variables figured out now, rate of change, again, is always dependent over independent. So this would be the change in the fee over the change in the miles. When we talk about change, we're just talking about subtracting them. So if we look at the top two rows, we're going to take the two values for the fee, and we're going to subtract those in our numerator. And you could really do them in either order. And we're then in the denominator, we're going to take the two values for the miles and subtract those. Now, the only key to this is whichever fee you put first in the numerator, you have to put that number of miles from that same row first in the denominator. So an example of this would be 42 minus 30 over 150 minus 100. And we subtract and simplify as much as we can. and we get 6 over 25. So the rate of change right now is 6 over 25 for the top two rows. Now if we do the middle two rows, the 150 miles and the 200 miles, that would again simplify to be 6 over 25. And then if you do the bottom two rows, we get the same 6 over 25. So this tells us that we do have a rate of change, a constant rate of change. It's always the same. So now because it's rate of change, I mentioned earlier that there would be labels generally involved. We have to know what this 6 over 25 really represents. This means that there's $6 for the fee per 12 miles that are driven. And again, we can see that all the rates of change are the same for the pairs of rows. Next thing we have to be able to do is look at a graph and be able to figure out what the slope is. This is called using rise over run, when you're just looking at the graph and not actually plugging in any numbers. So what I tell students to do is when they're using this rise over run idea on a graph is to start with the point furthest to the left. And then what you're doing is you're basically thinking to yourself, how do you go from that point on the left to a point that is on the line to the right of that initial point you're starting from? And since we know slope is rise over run, as we can see down here in our fraction, I always suggest that we do up and down moves first. So if we're moving up and down, okay, we have to understand that these tell us, depending on which direction we're going, which sign our number is going to have, whether it's going to be a positive or a negative value. Moving up is a positive value. Moving down is always a negative. So the graph in A, if I'm starting at the point 0, 4, because that's the one on the left, I'd have to go down to get to the same horizontal line as that point 2, 1, which is on the right of it. So since it's down, it's a negative value, I have to move 3 units, so it's negative 3. That, if you notice here, also got filled in the top of our slope fraction. Now from there, if I think about me being at the bottom point of this red segment, where do I have to go to get to that 0.21? I'd have to go to the right 2. So again, we have two possibilities. Could be right, could be left. Left would be a negative value, right would be a positive value. So notice that is also filled into the denominator of our slope fraction as a positive 2. So now we just look at our slope. Is there anything that we can do to reduce it? Negative 3 over positive 2, a negative over a positive remains negative. 3 over 2 I can't reduce, and we just leave it as an improper fraction. Do not change slope to a mixed number or a decimal. Always keep a fraction or an improper fraction. So along with using rise over run from the graph, we can also look at the coordinates of the points from the graph, which I have copied down here for us. And we can use the slope formula, which is y2 minus y1 over x2 minus x1. So we could take these values and plug them in. Doesn't want to cooperate. Okay, here we go. We have the values plugged in. Now if we simplify 1 minus 4, we get negative 3. If we simplify 2 minus 0, we have 2. So again, we have negative 3 halves as our slope, same as we got using rise over run looking at the graph. All right, let's try another one. So in B, if I'm starting at the point that's on the left, I would have to go up 2, so it's a positive value. I put that in the numerator of my slope. And I'd have to go right 1, so that's, again, positive. I put that in the denominator of my slope. Now we just have to simplify. 2 over 1, both positives would be a positive value. 2 over 1 is 2. Then again, using the coordinates, this time I actually flip the order. I will take the first point and call that x2, y2. You'll see when I show the work. And then the second point will be the x1, y1. It does not matter which point is your x1, y1 and which one is your x2, y2, as long as you keep x1 and y1 from the same point and x2 and y2 from the same point. Because I also wanted to show this, just a quick reminder, when you subtract a negative, it's like adding. So 2 minus negative, or sorry, 1 minus negative 1 is like adding 1 and 1. So you'd get 2. Negative 1 plus 2 in the denominator is 1. So again, 2 over 1 is 2. Your last example for something that you need to be able to handle as of today's notes would be to take 2 points where you don't have a graph and be able to calculate the slope of the line that would go through those 2 points. So first thing I suggest students do is to label their points x1, y1, and x2, y2. So I've already done that. Moved on me again, I guess. Here we go. So now keep in mind, like I just said on the previous screen, you could flip these around. It does not make any difference which one you have be the x1 and the y1, as long as the x1, y1 come from the same point and the x2, y2 come from the same point, everything will be fine. So now, once we have those labeled, just makes it easier for people to correctly plug into this formula, y2 minus y1 over x2 minus x1. So in this case, I would have negative 1 minus negative 2 for my y's. So again, that becomes addition. And negative 2 minus 3 for the x's. So negative 1 plus 2 is positive 1. Negative 2 minus 3 is negative 5. So my slope would be negative 1/5. It doesn't matter where the negative symbol is, as long as there's just one of them, it represents the same value. So now what I'd like you to do is either, if you need to, rewind the video, rewatch some of the examples, look back in your notes, or if you feel like you know what you're doing, without either of those, try these quick check problems, complete all of them, pause the video while you're working on them, and then once you've finished all of them, play this video and check and see how you did. So for your first problem, finding your slope using those 2 specific rows that you were given, you again would have 6 over 25 for your slope. So that again would represent $6 per 25 miles. Finding the slope of these lines using rise over run. Line A, which is our line with a positive slope, you'd have to move up 3 and right 5 from that leftmost point to get to the point on the right. And then B, you'd be moving down 1 and right 6, so that'd be a negative over a positive, results in a negative slope. Part B, a little bit more difficult for people, but even as important as the first one, maybe more important than the first one, because these are the ones that people forget a little bit more often. For line M, that's a horizontal line, so the slope is automatically 0. How you would show that using rise over run would be that you can not move up or down at all to stay on that line. And then you could move left or right as much as you wanted. So this bottom value could be anything you want. Could be a negative, could be a positive, could be any value. So 0 divided by any number is always 0. Line N is a vertical line. So we hopefully know that that is undefined slope automatically. And again, using rise over run to show it, you could put any value in your numerator. You can go up or down as much as you want, positive, negative, doesn't matter. But then left and right, you can't move at all, so that would be a 0. 0 in the denominator is always undefined. And then your work showing how to find slope. Again, C and D are just more examples to help you hopefully remember when you get 0 in the denominator, the slope is undefined. When you get 0 in the numerator, the slope is 0. So once you finish this video and all those quick check problems, you can go ahead and start this homework.